So my name is Matt Jezyk. I'm an architect by background. I've been doing software for the last 15 years or so, and I know a lot of people in the audience. You might think, what does Autodesk, as sort of a big commercial software company, what do we care about sort of open source development? So that's kind of one of the things we want to talk about today, specifically in the realm of Dynamo. There are some other fun projects that we can also talk about. But basically, one of the things that we talked about throughout the course of this overall exercise is why open source, what do we really gain from that, what's the benefit? So as you might think of Autodesk like this, like there's 100 different boxes that you can buy, and Phil Bernstein actually likes to talk about Autodesk as we're the arms dealer kind of thing, and we provide these kind of things out. But a lot of us actually inside the company, we're makers. We like to design things. We like to make things. And I've been using things like processing and Arduino for a really long time, since processing came out a long time ago, about a little more than 10 years ago. And then things like Arduino, a great amount of open source ideas out there. And ever since, obviously, things like Linux came out, things like Java when it was open sourced, we've been around for a long time. So the idea of inside the company, there are many people that are using these tools. And certainly we use a lot of tools, like we said before, for deploying websites, for building our back-end actual software. We use a lot of open source. But one thing we're starting to do now, which is a significant development change from, say, 4 or 5 years ago, is to start building more and more of our tools in a way that is literally right out on things like GitHub. So we'll talk about that through the course of this effort. I also want to bring up things like Scratch, which I don't think anybody's really talked about here, but this came out of MIT. The Media Lab, another great visual programming interface, primarily for kids, and there's actually a junior Scratch as well. So this was meant for like middle school kids, and now there's another one that's even simpler than Scratch. But the idea of how can we build a community out of these tools and help not just have 4 or 5 people work on it, but get a larger team together to contribute ideas, not necessarily just code, but ideas, and build up a larger user base and strong community around it, is ultimately where we see a lot of these things going. So that gets us to things like Dynamo. The sort of origin story around Dynamo is Ian Keogh, a friend of mine from a long time ago, and now a collaborator inside of Autodesk, was working in Baruch in New York. He was working on a couple projects. One of them was this transit station in LA with HOK. And then he moved out to LA and was doing some stuff. He was doing these types of work that are fairly sophisticated projects using things like Grasshopper and CATIA and Revit all together. Like we've heard a lot about in these types of symposiums and conferences. But what you don't really hear about in a lot of these, you see all of the great visuals, and here's how we achieve this success. You don't see the dirty laundry of these types of bespoke, little itsy-bitsy tools that everybody has to make to pull information out of CATIA and take it into Tekla or move it over to Revit. And a lot of these were this is about 6 years ago now, they were very bespoke, specific tools, which is the nature of these projects. They have their own specific needs. But the problem was that Ian knew that, look, he's going to build these things now, and there's other people in every firm that do these things. But 2 years from now, someone else is going to do the exact same thing again because they don't know that somebody else did it before. So how can we not just build these bespoke little tools? How can we build a platform that is open and accessible, but that helps people share and collaborate so that you can cut down on the amount of rework and the amount of lost work in this effort? So you do get these kind of great, look, the LOD 300 type projects, down to fabrication type things. So they ultimately, through perseverance and sheer will, you can get these things done. But how can we do it better and faster? We've already talked a lot about things like scripting, how you can do parametric computational design in a variety of different ways. This is one of them. Visual programming is another one. A lot of great tools around there, not just in AEC, across the larger computational space for the last 15, 20 years. Even back to sketching, we've talked about this a lot before too. I was just in Italy this summer and looking at things from Alberti, Santa Maria Novella, this particular facade. He had minions of people that could actually model those things and draw them, build them out of stone and other materials. We don't all have minions. We have computers. So how can we teach the computers to do these types of things and do them well for us? So that's actually where Dynamo comes in. So Dynamo, open source. This is where it gets interesting, where Ian had this idea, hey, I want to knock together this thing. He actually showed it to me at Acadia in New York about 5 years ago. Hey, I got this thing. It's like Grasshopper for Revit. OK, great. So let's take a look at it. What we ended up deciding to do is collaborate on it together as an open source project. He was working at Baruch, then at a company called Vela Systems as a software engineer. He didn't really have time to work on this thing full time, so he put it up on GitHub. I put some time into it. My colleague Zach Krohn put some time into it. We had an intern, literally a guy that came in, and in one of those fabulous 20% sort of time periods, he said, you know what, I think I could probably get Dynamo to do some cool things. So as a sort of side project, things like Dynamo can come out of a larger effort. And what turned out from that is, we started out with something that really didn't do anything, and now it actually is pretty sophisticated and powerful and is being used around the world, which is really great in the course of 3.5 years or so. But the fun thing about that is that it literally came out of needs from people like yourself, contributing ideas, comments, concerns, sharing code, sharing ideas, and delivering them on top of an open system. So this is a system that is 100% open source in the core. It's freely accessible on GitHub. I have a development team back in Waltham and in Shanghai or Singapore that are contributing to this code, but other people are contributing to it around the world. And it's not an Autodesk thing. It's just something that we think provides value to AEC and also to the larger community. So a couple other things I just want to get into really here too. You don't have to be a coder to get into this. You can access things from the visual side of it. You can access things from just grabbing a little Python code from the web. You can use things like literally from this package manager that we have to download. Chances are someone else has probably already solved the problem that you have, and you can just find it. And if they haven't, then you can create something and publish it yourself. So it's a virtuous cycle. It builds up the larger community. A lot of you have already seen this type of thing, but the idea here is that we inside of Autodesk, we'll build a tool like Revit or Inventor or AutoCAD or Maya, and it's going to solve some specific needs. And it becomes an industry standard. But there's always going to be specific needs that you need to solve for a project that you have. And that's where something like Dynamo comes in, where then you can actually add your own rules. You don't have to wait for us inside the company to say, no, a wall should work like that, which is a really great idea. So that's what Dynamo is. And it's not just on top of Revit. I'll skip a couple of these videos just for purposes of time. But the basic idea is that it's expanding. So runs on top of Revit, runs on top of other tools. We actually have another standalone product called Dynamo Studio, which is literally just taking the open source core and just wrapping it in an installer and giving you a geometry library more than anything else. So you can run it like a little parametric sketchbook outside of Revit. So if you've got people in your office that have like an allergic reaction to Revit, which totally, I see that a lot, which is fine. You can give them this little thing and say, hey, have a play. It's actually kind of fun. And that's the same idea of things like processing or Scratch, where it's this little itsy-bitsy thing that you can expose people to a larger idea. And a lot of what they do is do things like this, where you create a parametric model, you create something you can flex and explore, do some design variations at the building scale, take that building, turn it into an actual Revit project, and understand what it is from a quantity takeoff standpoint. Really, really common workflow that we see across the board. 90% of the building is done in Revit, purely prosaic model, and then there's special objects that are being created using computational tools. So it's a way, Andrew Human mentioned this earlier, to combine the computational design people in your office with your BIM guys and have them talk the same language, which is a kind of a fun thing. And operating at different scales, down to the level of million details, even in different industries. So now Dynamo, because it's separated from Revit and it's separated even from Microsoft sort of operating systems, can run in different industries. So we're seeing automotive designers, shoe designers, other people pick this thing up and start using it. And I just want to get back to that open source community aspect here too. So we have this thing called a package manager, which is just a big web service. You can put things up there. You can take user created content, custom nodes, content like Python or other nodes that you create to do certain things and put them up there for free. People can download them. It's a large virtuous cycle. I just want to give a couple shout outs to people that are here that are actually going to be leading the hackathons and speaking later today. So guys like Nate Miller and Andrew Human and Conrad Saban have been spending their own time and effort building these tools that are actually solving real world problems. So taking information from Rhino, bringing it into Revit, doing visualization, a lot of the stuff that Mustafa has been doing as well, all fits into that overall cycle. Things like fabrication, flattening projects out, dumping things out to Excel. Excel is the glue that holds a lot of this industry together. So we see that a lot from people in this audience, and then from the entity formerly known as CASE. They spend a lot of time doing these things. Things like Tableau, so visualizing data. It's a great way to pull information out from one source and pull it into a different one. Obviously, a lot of geometry. This is Lunchbox, one of Nate Miller's great creations. Another one, this is Rhino, another open source project that is literally, all it's doing is just connecting the Rhino data model to Dynamo, but letting you do it strategically. So you don't just end up importing this big blob of stuff. You can say, no, no, this is the thing that I want, bring it over, and then make something smart out of it. Visualization of information, huge thing that a lot of us spend our time on. This is a solar analysis type of thing. So taking core components that have been around for a long time in things like Ecotect, or we've built them inside of Autodesk, but then wrapping them in a way that lets you get access to the data. So that's a key thing. And then building your own analysis, right? So this is a view corridor, so just running through and understanding where you can actually see things from. This is actually really cool. This is straight hot off the presses. I just got this email 2 days ago. So Dynamo running inside of Maya. So I mentioned the fact that you can pull Dynamo out and put it down somewhere else. So this is Robert Silvione from Pratt. Has Dynamo running inside of Maya, and even to the point where it can do real-time analysis. This is a solar analysis using the Maya NURBS geometry from there. Analysis, analysis, analysis. We see a lot of this, a lot of optimization. This is a Thornton Tomasetti tool connecting to SAP 2000. Again, another open source project. So this idea of doing something open source, getting it out in this package manager, having people use it, and getting feedback creates that nice, tight cycle. Mustafa and actually Anna and Elson worked on this before as well. This is connecting a Revit model to back-end whole building energy analysis, but doing it computationally. So you can set things like, you know what, if your building is facing on the north side of the building, change the shading, change the window to wall ratio, optimize that based on a set of rules that you provide. And I'll skip some more videos here. We see a lot of people spending time on this right now. So analysis, analysis, analysis. Hooking up these disparate tools, but doing it via these open source connectors so that it's all transparent. You can see the data, you can access it, and you can trust it. That's a key thing. Running on top of different platforms again. Dynamo running on top of AutoCAD using a product called Advanced Steel, which is pretty cool. Again, same idea, just picking it up, moving it over, because it's open source. This is actually a really great visualization from another colleague at Thornton Tomasetti. So showing, this is column loading, where you're showing the capacity of a column versus the load on it. So you can talk to an architect and say, this is why your column needs to be 3 foot wide. You can't actually make a turn in this parking garage because that's holding up the whole building. So that's the kind of thing that you don't have to create your own custom solution for anymore. You can use these things off of the internet or pull them together to do. Even things like acoustical analysis. There's guys, Flanagan and Lawrence in the UK. Fabrication, another thing. So this is actually, so I wrote this. This is connecting Mathematica and Dynamo together to come up with an overall surface, and then create from that a set of toolpaths that were used to drive a robot. Other people are doing full fabrication of environments using these things, again, off the shelf, but contributing things back out to the community. Getting back to the hackathons, so this is a tool that actually Ian Keogh and Brian Ringley worked on last year at the TT Hackathon that just connected Dynamo to an ABB robot, or a robot studio in this case. We took that further, and now it's actually driving real robots to cut things like foam. And there are other people that are actually driving, using the same idea of just accessing this, just picking up that core technology and using it to drive. In this case, this is a different type of robot, a KUKA robot instead. So a lot of people are pushing into fabrication now. And it's for the same reasons that we've heard about before. So mass customization, it's going to cost you the same amount to produce 50 things that are different that it used to cost to do 50 that are the same, because you're telling the robot what to do. And actually the cool thing here too is this is an industry standard tool called Delcam to drive robots, like actual, running whole huge factories on these type of things. but wrapping that core technology in something that people can access from a designer standpoint and hack and work with is actually a really promising idea. So that's what we're seeing these things start to turn into now, to turn into things like this. And this is actually a company called MX3D. You might have seen some of this online recently, but they're actually using industry standard technologies for fabrication, but using it in a slightly different way. I'll just speed this up a little bit. So instead of using, this is basically just a big robot with a MIG welder on the end of it, but instead of using it to spot weld plates steel together, they're using it in an additive manufacturing way. And they're hacking that together. They're using a lot of Rhino, a lot of Grasshopper. They're using a lot of Dynamo in that process too to teach a robot how to start making things like a 3D extrusion in space, or build up a profile that is whatever shape you want to be, or from an optimization standpoint you've defined as this is the minimal amount of material to use. So it's interesting to see these cobbling together of different tools to do something that you might not have ever expected at all. And in this case, these guys are literally massing this project up to start building bridges with just 2 robots. So this little test prototype they have, which is actually pretty slick, I walked over that. And this is the actual project that they're working on. So in Amsterdam, they're going to take these 2 robots and start them on 2 ends of a canal and just have them autonomously build a bridge together just using stock components and ideas from different industries, putting them together via open source technologies. Back to the community idea. So lots of conversations and sharing of information happen in rooms like this, where people get together and figure out how to hack and how to work on things. This is actually a couple different hackathons like this, where this was actually at Mode Lab's office a couple years ago, but learning how to use these tools and how to apply them in different ways isn't just about technology, it's about people. And that's the key thing. Getting back to what Anna and Mustafa showed before a little bit as well. So this is a previous hackathon back in February to where they did the Google Cardboard stuff and the other cloud-based technology. So even taking guys from different industries that have never even heard about how to make a building, and then they throw them together because they've got different tool sets together. So it all comes back to community, all comes back to learning, all comes back to how can we share these informations instead of holding them as our own little secret over in the corner, and then share them appropriately. So with that, thanks.